Hello, Miss Mann's 8th grade science class. I'm going to briefly talk about the Solubility Lab that is recently assigned. If you are in my class, in my in-person class, you just got this today or either tomorrow or the next day. For my online students, I assigned this to you today, and it will be due on the 8th, okay? So September 8th. Now, here is what's going to happen. First, I have given you a PDF. All right, this is how the document came as a PDF. Unfortunately, I cannot convert it to Word, so you're either going to need to A, print it out, and then write on the packet as you would normally, and then scan the papers and submit them that way. Or if you do not have access to a printer, you can definitely use a spare sheet of paper and write the answers out on there and submit it that way by taking pictures of it. Now, here is my standards for that. I have to be able to read it. I have to be able to understand it. I can't grade what I can't read. So if it's a bunch of chicken scratch, then I can't read it. And if it's clearly written and I can actually read the individual questions in your lab, then we're good. All right, so do your best to make it legible. All right, so let's go ahead and start looking at this lab. I have it right here in the packet form. So it starts off, I'm going to read the introduction to you. In today's lab, you'll be working in groups to determine whether sugar or salt dissolves more quickly in water. The rate at which different substances dissolve depends on a number of factors. You should know several of these factors. For instance, which dissolves quicker, a sugar cube or granulated sugar? What other factors affect how quickly solutes dissolve? You can easily look this up on Google, or you could just give it some critical thought. For example, the number one factor that affects solubility is temperature, right? Temperature. So, the number 2 fact, the second one that affects solubility, right? I would say is the amount of surface area. So for the first one, let me get my purple pen here. The first one, we'll say temperature. Right? And for the second one, we will say surface area. Because think about it. What do you think is going to have more exposure to water? A sugar cube or granulated sugar? And for those of you who are not sure what granulated sugar is, just imagine taking a sugar cube and smashing it with a hammer. That's what granulated sugar is. It's just pulverized sugar cube. So, we have temperature, we have surface area. I gave you 2 out of the 3 things. You can think of the third thing. For instance, how much solvent do you have, right? If you have a glass of H2O, you have a glass of H2O, and there is water, which is H2O, and then you want to add salt, sodium chloride. The solvent would be the H2O. That is what you're dissolving the sodium into, right? The solute is going to be the sodium chloride. So again, the solvent is the liquid, it's the H2O. The solvent is whatever you're putting into the liquid, right? All right. So you're going to fill in this third thing by yourself. You're going to have to think of that third thing. I'm going to make you do that. Now, the rate at which solutes dissolve is related to, but not the same as, solubility. Solubility is defined as the maximum quantity of solute that can dissolve in a certain quantity of solvent at a specified temperature. Differences in solubility of different solutes are related primarily to differences in chemical nature of solutes and solvents. Water is a very good solvent, and many different substances dissolve quickly in water. Which do you think will dissolve more quickly in water, salt or sugar? Write down your prediction and the reason for your choice. So, if you are struggling to figure out, well, how would we know the difference? How can I even make that prediction? Well, you could start by looking at the chemical formula. Again, I said that salt is NaCl. That's simple, it has 2 atoms, right? Sugar is a lot longer than that, all right? So I'll go ahead and look up a sugar molecule for you, all right? Sugar molecule, right? It's C12, H22O11, right? That is just the basic glucose molecule. All right, so here's what we're going to do. I'm going to write this down. So it's C12, H22O11. That is the molecular formula for sugar. And NaCl is the molecular formula for salt. So which one do you think is going to dissolve faster? I need you to write down that in your prediction. And remember, your prediction doesn't have to be right. All right? The only thing I want for your prediction is for it to be in a complete sentence. If you have a wrong prediction, that's fine. All right? Half of predictions are wrong. Half of hypotheses is wrong. That's completely fine. I just need you to write in complete sentences and writing down your hypotheses. All right. Now let's go to the lab procedure. Your group will need the following, or your family, because that's who you're going to be working with. You need one extra person to do this, at least. So, lab procedure. Your group will need the following. 2 clear cups, each with 2 cups of room temperature water. They need to be clear. The water needs to be room temperature. So you can set out a glass of water overnight and have it go up to room temperature so that they're the same temperature. And you need the 2 clear cups because you need to be able to see if the solute is dissolves into the solvent, right? So you need 2 stirring rods. Stirring rods can be the same as spoons, all right? It could be spoons. It doesn't have to be a rod. It could definitely be a spoon. 4 containers each with 1 teaspoon of salt. So you're going to have 4 separate containers. It doesn't matter what the containers are. It could be Tupperware, it could be bowls, it could be plates. It just needs to have 1 teaspoon of salt. And same thing goes for sugar. So you need 8 total containers. 4 containers with salt, 4 containers with sugar. And you're going to need a stopwatch. You can use your cell phone, you can use your parents' cell phone, or you can use a regular stopwatch. And then colored pencil. Colored pencil is going to be for the graph. My apologies. I hate it when this thing pops up. All right, so let's go back to the solubility lab. Collect data. Within your group, assign 1 person to add and stir the salt, and 1 person to add and stir the sugar. 1 timer and 1 data collector. So again, you need at least 1 other person, but it would be better if you had 4 people, right? 1 to add the salt, 1 to add the sugar, 1 recorder, and 1 timer, right? Salt. Here is what you're going to do. You're going to add 1 teaspoon of salt to the cup of water. Start the timer and begin stirring immediately. Do not wait. Just keep stirring. Just start stirring. Watch the solution. When all of the salt appears to have dissolved, stop stirring, but do not stop the stopwatch, right? You need to let that stopwatch keep going. Check to see if all the salt has dissolved. Again, the stopwatch is still going. If it has, note the time. Do not stop the stopwatch immediately. Add the 2nd teaspoon of salt. Again, do not stop the stopwatch. Immediately add the 2nd teaspoon of salt to the cup of water and begin to stir. Now, you are only going to add the 2nd teaspoon of salt when the first one has dissolved, right? So you're going to wait for the 1st teaspoon to dissolve. Once that has completely dissolved, that is when you're going to add the 2nd one. Remember to record each time it takes for a teaspoon to dissolve. If the salt has not completely dissolved, start stirring again until it is dissolved. You cannot add more salt until the original teaspoon of salt has been dissolved. Continue this procedure until 4 teaspoons of salt are completely dissolved. Record the total elapsed time. A teaspoon of salt completely dissolves. Record your data in table 1. So, for instance, right? So let's go back to here. And as you can see, it finally sorted itself out. So say I stop the timer, right? Say it takes, this is a rough estimate. This is no way accurate. I'm pulling this out of my head as we go. So this is not reliable data, okay? I'm expecting to see actual data. So say you start, you put the solute in, right, into the water. You put your first teaspoon of salt into the water, right? And say it takes 10 seconds for that to dissolve. It takes 10 seconds. And then say you put in your second teaspoon. Now, at that time, the timer might read something along the lines of, 22 seconds, right? You're going to want to write this here to keep track. 22 seconds is when the second teaspoon of salt is fully dissolved. However, elapsed time means how much time has passed from 10 seconds to 22 seconds, right? So the elapsed time would be 12 seconds. All right? Say we have a cup 3 and it takes 33 seconds, right? This time it takes 33 seconds. Well, let's say it stops at 40 seconds, right? We stop the timer at 40 seconds. So we need to figure out the elapsed time between 22 seconds and 40 seconds, which I believe is 18. So you are taking the difference between the two times on the timer where a teaspoon of salt dissolved, right? So let's say you got to the 4th teaspoon and this time you don't get it dissolved until a whopping minute and 20 seconds, right? So if you have it in a minute, you need to convert all of this to seconds. You already have 20 seconds, right? So we need to convert 1 minute to 20 into seconds, right? So you have 1 minute. Here's how we're going to convert. We are going to do, for every 1 minute, there's 60 seconds, right? So you have 60 seconds. 1 times 60 is 60 divided by 1. That equals 60 seconds. Now, you still have this 20 seconds left, right? You can't forget about that. So 60 seconds plus 20 seconds equals 80 seconds. So that is the elapsed time for the 4th teaspoon of salt is 80 seconds. Do you see how I did that? When you cross into the minute territory, you need to be able to convert the minute, right? You need to be able to convert that minute into seconds to get it all into one unit, because that is what we're measuring in, seconds. All right, so you have your data collected, you calculated all your elapsed time. Now, you're going to plot your data from table 1 for the salt and sugar on the graph. Separate sheet at the end of the lab worksheet. So if you flip it over, you will see it at the end, all right? And add a title to the graph. Well, I've already done that. A good way to title the graph is just what the table is measuring, right? So I said amount of solute versus elapsed time. Or, you know what? I'm going to go ahead and erase that, revising it. Solubility of sugar versus salt. That completely tells you what this experiment is, right? Which one's faster? Solubility of sugar versus salt. Which one dissolves faster? Here you have elapsed time, which again we calculated, and then we have amount of solutes in grams. This is going to be a line graph. So say your total time. All right, so we have our titles. Let's just focus on that right now. We have our titles, right? Elapsed time on the y-axis, amount of solute in grams on the x-axis. And it even, if you forget, it even tells you in the instructions right here. The amount of solute is a variable that you manipulate. You measure the elapsed dissolving time for each gram of solute added. Based on this information, you should plot amount of solute in grams on the x-axis. So you see how it kind of tells you there? It even gives you a little hint. So it just directly tells you what to title that x-axis. So you don't even have to think about it. And elapsed time in seconds on the y-axis, right? Decide on an appropriate interval for both the x and the y-axis, right? So essentially, amount of solute in grams. Well, we don't really have grams, right? That's on the x-axis. So you could go ahead, because it says, because you are using tablespoons, right? So amount of solute in grams. Are you using tablespoons or are you using teaspoons? Teaspoons. So you could put amount of solute in teaspoons, right? Because we're not using grams, we're using teaspoons. Amount of solute in teaspoons. We're doing this by volume. And we know our max amount of teaspoons we're going to use is 4. So you have, what I do is you need to convert this whole thing into 4 equal parts. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So 4 doesn't go into that evenly. So we can take 2 out because 4 goes into 20 evenly, right? So if you go 20 divided by 4, 4 goes into 20 5 times. So you need 5 total lines, right? So if you have 20 and you do 5 lines, we go 1, 2. So you have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's going to give you your intervals. So your first one is going to be 1 teaspoon, and you don't need to rewrite the units because you already have it in here. Remember, we are doing amount of solute in teaspoons, not grams. Okay, I made a mistake when I said that earlier. It's teaspoons. It's teaspoons. So you got 1, 2, 3, 4. All right. That looks beautiful to me. It looks pretty even. It looks like it takes up the whole graph. We're good. All right. We are good. As a thumbs up if you couldn't see. Now, elapsed time in seconds. Right? This is going to be a little different. This is going to be different for everybody. Okay. Because everybody gets different data. So it actually tells you how to do it right here. So decide on the appropriate interval for both x and y axis. We already did that for the x axis, all right? It's going to be the same for everything because we only have 4 teaspoons, correct? So for salt and sugar, it's just going to be 4 teaspoons. Now, decide on an appropriate interval for both x and y axis. The scales for x and y start at 0 and must go to the highest value of the variable. We did that. The value you increase from line to line should be by the same interval on an axis to determine the value of the interval. Take the highest value and divide by the total number of lines along the x-axis. For example, if your greatest value on the y-axis is 315 seconds, right, and there are only 30 lines in the y-axis, you are going to take 315 divided by 30, and you're going to get 10.5 for each line in the y-axis. So that means, right, you are going to go over here. This is your y-axis. So each of these lines is going to be 10.5, right? And then you're just going to add 10.5 every time you go up a line. So what's 10 plus 10? That's 20. And then we have an extra 1. So that's going to be 21. Does that make sense? And then this one, right? What's 21 plus 10? That's going to be plus 21 plus 10 is going to be 31 plus 5. That's going to be 31.5. All right, so does that make sense? I personally prefer whole numbers, but if this way makes so much more sense to you, go ahead. All right, the world is your oyster when it comes to graphing. That's what I like about it. All right, so make sure you use the whole graph, which we did here, and make sure that you have everything labeled. Once you are done with your graph, oh, and one more thing. For the graph, you are going to have 2 separate lines, all right? So again, this is just an example. You're going to have 2 different colored lines. So for instance, my purple line, that is going to be my salt. I have a red pen here. We'll make that sugar. All right? Easy peasy. So for my salt trend line, I'm going to be using purple. All right, so say this is my general trend line. Again, this is not accurate. This is just me demonstrating how I want the graph to look. So salt is purple, so I made a purple line, right? So I made a little bit exponential. So I made a purple line, so I can clearly see that this trend line is salt. Now, for sugar, I have red, so you're going to do the exact same thing. Say sugar took a little bit more time, right? You're going to have the sugar in red. So I can tell which line is which. I need these color-coded. That's why we have to pick colored pencils in the materials. So you are able to color-code your graph so I can read it easier and refer to the legend to know what each line stands for, right? Excellent. All right. Now let's go analyze the data. You're just going to answer questions. This is where you're going to be looking at your graph, right? Which dissolves faster in water, salt or sugar? Just write down which one dissolved faster for you, okay? What do you notice about the steepness of the lines representing salt and sugar? Just write the general trends of the line. Did they dissolve faster at the beginning? Did they dissolve, the dissolving rate slowly slow down? What do you guys think? Approximately how much salt was dissolved in the water at 45 seconds? Again, just give me your best guess. So, if you don't know the amount in 45 seconds, look at your data table, right? And you have the term right here. So, like, oh, well, I got 3 teaspoons. It dissolved in 30 seconds, right? So you can just do that. Do the number you got closest to 45. So, for my answer for that would be 3 teaspoons. Now, you're going to ask the same question, right? Approximately how much sugar was dissolved in 45 seconds? Again, you're going to add up how many teaspoons were dissolved within 45 seconds. On a graph, how do you know if the solute was dissolving at a constant rate? So how do you know that a solute was dissolving at a constant rate? Meaning the same amount of solute dissolved at the same increment of time. It stayed constant. So you could have 2 teaspoons of salt dissolving in the water per 30 seconds, right? So you would need to know how to see that on a graph, right? So make sure to use your graph. If a different solute dissolved much faster than salt, where would be the line on the graph compared to the line of salt? All right? So just put above or below, but I need complete sentences in order to give you credit. Number 7, at any given temperature, there is a maximum amount of solute that can be dissolved in water. When no more of the solute can be dissolved, water is said to be saturated. And with that solute, what would your graph for the rate of dissolving salt or sugar look like after the point of saturation? So you're just going to predict what your graph would look like, all right? You're going to see what it looks like, how the trend goes whenever you add more salt, and then you're going to continue that trend by visualizing it if you went on to saturation, right? All right. So this is just a brief video on how to do the solubility lab. If you have any questions, comments, concerns, please do not hesitate to email me. I need that communication if you are struggling, all right? So I really hope this video helped. If it didn't, let me know, and we can talk during office hours. That is on Thursday, all right? Thank you so much. Have a great day.